Okay, in example 7, it asks you to simplify the following formula. It says, it's the law of cosines, and it says, suppose angle C is 90 degrees. What we really have here would be a triangle. Well, we'll talk about that in a second, but we know it's a right triangle. But let's put that in there. And what is the cosine of 90 degrees is really what we need to know here to solve this. C squared equals A squared plus B squared minus 2AB cosine 90 degrees. Okay, so what is the cosine of 90 degrees? Now some of you have done the unit circle, and you look on the unit circle, the cosine is the x value. And so one way to look at it is like this. On the unit circle, a 90-degree angle is right here, which means we want this value right there for that coordinate, which was on a unit circle it's 0, 1, and the cosine is the x value, which was 0 in this case. Another way to think about it is we have a right triangle here, okay, and we have a side A and a side B and a side C, and we're asking about C squared in the law of cosines. Okay, well, it's right here on the right triangle, and if it's a right triangle, what do we know is true? Well, in a right triangle, C squared equals A squared plus B squared. And we don't have this extra piece right here that we have to worry about. So you can see that the law of cosines works for right triangles, but it's a special case where we don't have to worry about this correcting factor that we usually have in there. That's for obtuse and acute triangles. So I'm gonna show you that it actually simplifies in. So we take the 0. This value right here is 0. So we get C squared equals A squared plus B squared minus 2AB times 0. Well, if that's 0, then this whole thing goes to 0. So I end up subtracting 0. C squared equals A squared plus B squared. Well, do I really have to subtract? Do I really have to show subtracting 0? No, we just drop it and we get back to the Pythagorean theorem, which is really the special case of the law of cosines. For any right triangle, the Pythagorean theorem is the law of cosines with 90 degrees in, which makes the rest of the term go away because you're multiplying by 0. So the minus 2AB cosine term goes to 0.